We continue our examination as to why the transition from basic math to algebra is so important, and why often in conversations, regardless of where you are in a line at a social event, people often say that I was good in basic math but had difficulty making the transition from basic math to algebra. And we've examined one aspect as to why this is so important and why we do this at all. And we'll continue that at this point in time. As we indicated earlier, that in basic math we're essentially dealing with adding, subtracting, multiplying, and dividing real numbers. And mastery at the basic math level says that you can do this really, really well. Real numbers being all of the numbers associated with those values that are depicted on a number line. Zero, of course, your positive and negatives, and all the numbers that you work with at the basic math level before going on to your higher mathematics. And the two things we say that the algebra accomplishes here. Number one, we spoke in earlier videos about the efficiency aspect of it. Efficiency. That is to say, it just covers a whole host of problems, rather than in basic math your teacher giving you 100 or more problems of the nature, the type x plus y, for example, x plus y. This expression can represent a whole list of problems, a whole infinitely many problems. And of course, as we know, x and y are variables, so all you have to do in order to generate a problem is to assign a value from the number line. Now, from this number line, you will assign a value of x, and x could be anything. You could make it x as a 3, and y can be another value. Let's have y be, and again, we want to make it clear that in this number line has all sorts of numbers on it, and we can work with them, all of them, and irrational numbers are also there. So y could be a pi. And we're doing this because we want pi, recognize that pi is a number, and if you're at the basic math level, you should know this. And therefore, if you are to simplify this problem now, as odd as it may seem, and you would go ahead and just make the necessary substitutions. We know that we'll go ahead and go back to the original, that we have x plus y, and x is 3, so we're going to go ahead and substitute. We'll put 3 in here for x, plus y is pi, and your answer would be 3 plus pi. So you can represent it this way, 3 plus pi, which would be your solution. All right, and of course you're very good basic math students, so it goes without saying that you know that pi is approximately 3.14. So, 3.14, we need a 1 in there. Okay, so if you want a decimal representation of this, then clearly this would be 3 plus 3.14, which means that it would be approximately 6.14. Okay. So that's, again, the first aspect as to why the algebra. Again, it has to do with efficiency. It's just that you can represent a whole host of problems, any numbers from the number line with your basic math. And of course, the operation can change. It could be subtraction, multiplication, division, so forth and on. And the other thing that we want to talk about in this video, the second aspect of it, this was the first, efficiency. And the second thing that we want to talk about now is clarity. Okay. Now we say clarity, we say, what do you mean by that? What we're alluding to is that algebra reveals something about mathematics around us, and once you have a good understanding of the algebra and the algebraic concept, if you will. So let's say you were given a problem in basic math. So you're giving this problem. Let's do this. Let's say that your mathematics teacher gives you this problem. Let's go with 10 minus 2 to 24 plus 5 minus 3. And your first instinct in basic math, this is a basic math problem. Okay, there's nothing but additions and subtractions in this problem, and therefore clearly all you need to do here is to simplify it. Okay, but let's take an algebraic approach or an algebraic view to this problem. Okay, we're going to look at it in a different sense, if you will. That is to say, if we were to represent this in another way, well, let's do it. Let's do this first. Your first instinct, of course, is just to do the problem, and we'll talk more about order of operations and in future videos. But let's just go ahead and do the problem and see what the answer is. Most of us would get if we were to do the problem correctly and from left to right. So we would end up with the 10 minus 14, which would give us a negative 14, plus 5, minus 3. All right. We'd go ahead and do this next. Our negative 14 plus 5 would give us a negative 9 and minus 3. And so our answer here would be negative 12. Okay. And that's fine. But let's go ahead and take a look at what we may have missed in this problem. Not missed necessarily, but let's see what the algebra would reveal if we did it algebraically, and what would be revealed. Okay. So an algebraic approach or an algebraic perspective would say to look for patterns and to look for things that are hidden within the problem. And one of the things that you might notice is that you have a 10 here, and those guys are both multiples of 5. So based on that, we'll let x be equal to 5. Okay. And then if we were to look at this 24, the 24 and the 3, those guys are all both multiples of 3. So for that reason, we'll let y be 3. All right. So based on these representations, these values, we can now go back and look at this problem as 2 5s. Okay. So 10, of course, is 2 times 5. So this is 2x. We would have that as 2x because x is 5. That's 10. Minus, okay, 24. If y is 3 and that's a 24, then this could be represented as a negative 8y. Again, 8 times 3 is 24. And we have x here again, and x is again 5. So we'll put our 5 here again, plus 5, plus x, excuse me. Let's go back. Apologize. Let's go back to our x. And finally, minus 3. So that's a negative y. All right. And therefore, if we were to simplify this algebraic expression, we'll again collect up our like terms. How many x's we have here? We have 2 of them there. Let's go to a different color. Keep the colors the same. We have 2 sets of x's here, 2 x's here, and another 1x there. So we know that this becomes 3x. And we went back too far here. We lost our part of our x. Apologize for that. Oops, sorry about that. We lost part of our y. Okay. So, and then we have a negative 8y minus another y, which would give us a negative 9y. And so, at this point, we have this expression which has been simplified. And if we were to want to evaluate it now, we would have to go ahead and substitute in our values for x. So in this case, we would have 3 times x, and x is 5, minus 9. Let's go back. We want to try to keep this color coded so that it reveals itself, if you will. Oh, well, y is 3 anyway, so it's still green. So that's fine. Let's not get too away from ourselves. And finally, let's go ahead and finish off our solution, our answer. Our final answer here would be 3 times 5, that would be 15, minus 27, which is, again, negative 12. Okay? And, of course, the answer is the same. We'll talk about that, how in math the answer is unique. But what we'd like you to recognize in this particular case, and well, what we're trying to demonstrate here, is that in basic math, if we were to stick with basic math only, and this is one of the major points here, if we only do basic math and we stay in that mode, we never get to the hidden beauty that's within the mathematics. And that's another very primary reason why we want to go from the basic math to the algebra. Because the algebra reveals things within the mathematics. It reveals patterns to us. And those patterns, believe it or not, and I know you do, exist in the world around us. And part of the deal with algebra, why algebra is so important and why we want you to make that transition, is that we would like you to be aware of these patterns and be able to work with these patterns, these concepts. And these concepts are all around us in the things we do. But if we only stick to the basic math mode and are only to stick to our basic math way of thinking about things, very specific and very literal, and never move beyond to the concepts, okay, we will be missing out in a major aspect of the beauty of mathematics and the beauty of the world around us. And therefore, we will conclude with this. It is nice, not absolutely necessary, but it would be pretty terrific to be able to have that perspective, to see how mathematics, how algebra helps us move from the specific examples to the general case, general rules, and reveals the beauty of the mathematics around us. Take care. Hope this was revealing to you, and we look forward to seeing you in the next video.